Hello viewers, welcome to K Diagnostics, Dio here. Today we have a 2008 Mazda 3 with a 2.3 liter. The customer complaint on this vehicle is that the check engine light remains on while the engine is running. So the first thing we're going to do is we're going to confirm the customer's complaint. We're going to go inside the vehicle, start it, and see if the check engine light will remain on while the engine is running. After confirming the customer's complaint, we're going to connect a scan tool to the vehicle to retrieve any trouble code that's in the engine computer. Because if the check engine light is remaining on while the engine is running, it means there's a problem in the engine management system. So there's most likely a code in the engine computer. We're going to use a scan tool to retrieve all the trouble codes. Once we get the trouble code, then we will know what directions we can go so we can fix whatever that's causing the check engine light to remain on while the engine is running. So now let's go inside the vehicle and confirm the customer's complaint. Alright, so we are inside the vehicle. Now we're gonna confirm the customer's complaint. I'm gonna start the engine. So right there, the engine is running and the check engine light remained on. So right there guys, check engine light remained on, so customer's complaint confirmed. So now we're gonna connect a scan tool to the vehicle to see what kind of trouble codes we have in the engine control module. So I'm gonna get the scan tool connected and then I'll bring you guys back up. Alright, so I got the scan tool connected to the vehicle. So now we're gonna scan the engine control module. Now we're gonna go to the engine computer. Actually, let's do a whole system scan. Let's click on code scan. This is going to scan all the modules on the vehicle. Alright, so the scan tool is done scanning all the control modules. We have 2 trouble codes in the engine computer. And we have 1 trouble code in the ABS. We have some U codes in the instrument panel. So we have 1 trouble code in the generic side of the scan tool. So the trouble code on the generic side is P0138 O2 sensor circuit high voltage bank 1 sensor 2. So the second O2 sensor on the exhaust stream, so basically the O2 sensor after the catalytic converter is putting out a voltage that's high, and that voltage is constantly high. So that's why this trouble code is set. So now let's go back and go straight to the engine control unit so that we can do some tests. This trouble code, actually let's look at the codes once again. So this trouble code, so right over here, we have 2 trouble codes. The P0132 O2 sensor circuit voltage high. I mean, this is the second O2 sensor. And the second trouble code is P2504 charging system voltage high. We're going to ignore this trouble code, this second trouble code, because this trouble code was set by me. The vehicle was sitting outside and the battery was weak, so I used the battery charger to jumpstart the vehicle, and I put it on the highest amperage scale, so which increased the voltage, and the computer saw high voltage, so it triggered this code. Let's ignore this. We're going to focus on this trouble code. This is what's causing the check engine light to remain on while the engine is running. So this is pretty much self-explanatory, okay? The O2 sensor is putting out a high voltage, and that voltage is constant because this O2 sensor, the second O2 sensor, is used to monitor the catalytic converter. The computer adjusts the mixture in the engine to keep the catalytic converter working at its top performance. And as it does that, it monitors the signal from this second O2 sensor to see how the catalytic converter is doing. So if the signal is constantly high, the computer is going to look at that for a certain period of time. If it sees that signal not changing for, let's say, 1 second, if the signal doesn't change after 1 second, it sets this code. Okay, so this is pretty easy to do. We're gonna test this sensor. If the signal doesn't change, we will replace the sensor. I mean, we can also test the wiring, but there are some tests we can do to double check the wiring. If the wiring checks out okay, the problem will just be the sensor. Now, just out of curiosity, I want to click on this diagnose button and see what we have. So right over here, this is the intelligent diagnostics side of the tool. On the left side here, we have some TSBs. So we actually have 3 TSBs about this trouble code. So which is good to know. And then the top repairs for this trouble code, this P0138, says when you have this trouble code set, your problem is most likely a defective sensor or an exhaust gasket, because it says replaced oxygen sensor or replaced exhaust gasket. So these two are the most likely cause of this trouble code. And I believe we're just dealing with a defective O2 sensor here. This top repair is good information to have. This info is gathered for us by Snap-on, so it makes it available for us to help us diagnose vehicles pretty fast, okay? And this information is gathered from other technicians like me, so they make it available to us to help us diagnose vehicles. But I just don't like to go by this info here. It's good to know, it's good to keep in the back of our minds, but I always like to do my own tests before I condemn a component. So let's click on this TSB. Let's see the type of TSBs we have over here. So we have 3 TSBs. Let's click on the first one and let's see what it says. So here's our TSB info. This is the year range that this TSB covers. So let's go straight to repair procedure and let's see what it says. It says verify customer concern. Inspect the air fuel sensor harness for damage. If the harness is damaged, bend the sensor harness connector bracket according to the following steps to prevent interference. Then replace the air fuel sensor with a new one. Refer to the service bulletin 01-051/09. And it continues, if the harness is not damaged, this information is not applicable. Refer to MS3 online instructions for troubleshooting procedure. Okay, so basically it looks like there is a harness that attaches the shield, the heat shield on the exhaust manifold. Okay, and then it says cover the tips of some pliers with vinyl tape A to prevent damage and future risk of rust to the surface of the bracket. Tips of pliers covered with vinyl tape. So basically, actually here is the exhaust manifold. Okay, and it looks like here they're showing us the air fuel ratio sensor. So this is the sensor before the catalytic converter, but the code we have is for the sensor after the catalytic converter. So we have to look at the harness of that sensor and we have to make sure that the harness is not touching anything. Okay, so that's basically what this TSB is saying. If we have a harness that's touching ground or that's being shorted to ground, that will compromise the signal that's coming out of the sensor. So let's back out of here. Let's look at this second TSB and see what it says. So here's our second TSB. So the repair procedure, it says oxygen sensor removal procedure. So it looks like on this TSB, it's showing us how to remove the O2 sensor. We don't want to look at that. We already know that, right? So let's back out. Let's look at the third one. So, well, anyways, again, like I said, this is a pretty self-explanatory code. There isn't much to this. Okay, let's back out of here. We know that the code is about the second O2 sensor. So now what I want to do is I want to look at live data. Okay, let's see how this sensor is acting. Is it the sensor that's sending a fixed reach signal? Because a high signal is a reach signal on this vehicle. Is it a sensor that's sending a fixed reach signal, or is it a wiring problem that's causing this? So now what we need to do is we have to go to data display, and let's go to fuel trim and O2 sensor data. So this is processed data. This is the data that's coming from the computer. Okay, so now let's graph the second O2 sensor data PID. So right over here, let's graph this. So O2 sensor bank 1, sensor 2, we're going to graph that. Let's also graph the PID from the other sensor, I mean the first O2 sensor. So here is the first O2 sensor data PID. So we're going to graph this. Now, I also want to look at our fuel trim numbers. I want to look at the short-term and the long-term fuel trim numbers. I mean, right now, I see fuel trim short, bank 1 percentage. Okay. So, right over here, we're going to look at that. We're also going to look at our long-term. So, I just want to look at these 4 data PIDs. Okay, so 1, 2, 3, 4. We're gonna focus on these data PIDs over here. So we have our short-term fuel trim numbers on the right, and then our long-term fuel trim numbers on the left. So now I'm going to start the engine. We're gonna start the engine and see how these O2 sensors respond to the oxygen content in the exhaust stream. So the engine is running. I hope you can tell. So we're gonna test these two O2 sensors. Now we're in closed loop. Okay, so our fuel trim numbers are starting to correct. So I'm increasing the engine RPMs. So as you can see, we have a flat line on the second O2 sensor data PID. So on this graph over here, there's no activity. We have activity on the first O2 sensor, but we don't have any activity on the second O2 sensor. And this can be caused by either a defective sensor or a problem in the wiring between the sensor and the computer. So now I am going to drive these O2 sensors lean. This vehicle has a brake booster, so I'm gonna pump the brake pedal, which will cause a lean condition. And right now, as you can see, we have positive numbers on the short term. Let's watch that. Okay, we have positive numbers, I mean positive low numbers, but once I start to pump the brake pedal, these positive numbers will go really high. So now I'm gonna start pumping. Let's watch that. You see how these numbers are going high? Because I'm causing a lean condition right now. I'm causing a vacuum leak because I'm pumping the brakes. And as you saw, this graph over here, this line over here didn't move. So we're pegged out right now on this short-term fuel trim number. You see we have positive 25%. Right there, we have positive 25% because I'm pumping the brake pedal, which is creating a vacuum leak. So right over here, we have a rich signal on this air-fuel ratio sensor, the sensor before the catalytic converter. But this sensor over here, after the catalytic converter, is not moving. Since we are creating a vacuum leak, there should be excess air inside the exhaust stream, okay? And we should see some activity or some movement here on this signal, on the signal coming from the other O2 sensor, the sensor after the catalytic converter. And as you can see, we have a flat line. So this is a problem. So now I'm pumping. Our short-term percentage is at 25%. So I'm gonna let off the brake pedal and this number will start going down. And as you can see, this number is going down and the sensor here is starting to correct. But we didn't see any movement over here. This line here didn't move. So this sensor is stuck. Okay, the sensor is stuck. So now what we need to do is we're gonna go under the hood and locate this sensor. Once we find this sensor, we're gonna do some tests at the sensor electrical connector. If the wiring checks out okay, then we will go ahead and replace the sensor. This is starting to look like a defective O2 sensor, guys. Now, there is a bias voltage that the PCM sends to the sensor. So what we need to do now is we're going to scope the signal wire at the sensor with the key on, engine off. If we see some type of voltage or some type of ghost voltage on that signal wire at the sensor, that will tell me that the wire is good, because that voltage will be coming from the computer down to the sensor, because the computer uses that ghost voltage. I mean, it could be 0.5 volts, or it could be, I don't know, it's just going to be a small voltage. The computer uses that voltage to test out the circuit. Okay, actually, if you guys want, let's turn off the engine first. The engine is off. If you guys want, we can look at the wiring diagram really. So we're gonna click on this wiring diagram. So we're gonna find the oxygen sensor in one of these pages. So this is a 4-page wiring diagram. Now here's our front O2 sensor, and over here is our second O2 sensor. So if we highlight these two wires, you will notice that these wires go to the computer. So we got these two wires highlighted. As we follow this wire, so black and orange, this one goes to the ECM. So right over here is the engine computer. So let's scroll up. We're gonna follow the other wire. Let's see where it goes. I believe it also goes to the computer. So right over here, this wire also goes to the computer. So white and blue. So white and blue and black and orange. So these are the two wires that we're gonna scope when we get to the sensor connector. Okay, so just ignore this. Okay, so we're gonna get to the sensor connector, back probe these two wires, this black wire with an orange tracer, and then this white wire with the blue tracer. As you can see, it's not telling us what wire is what on the control module here. So we don't know if this is the signal wire or maybe the other one is a signal wire. So we're gonna back probe one of these two, and one of them should be the signal wire. Okay, so now let's go under the hood and do the test at the O2 sensor electrical connector. So let's go under the hood and do that. All right, guys, so we're here under the hood and Ivan is just looking. Hey, Ivan. So we are going to do a visual inspection first. Ivan is not helping me. He's just looking around.
Short. I can't fit.
You can't reach over here. Ivan can't reach over here. He says it's too short.
Too short.
All right. So I'm looking at the connectors. This over here is the connector for the O2 sensor before the catalytic converter. And this one over here is the connector for the sensor after the catalytic converter. So down over here, this is that little bracket that we read about on the TSB. So I'm inspecting the harness right now. Everything looks good. I mean, it's not, the wires are not touching. Okay, so the sensor that's causing the problem, or the sensor that's causing the trouble code, is the second sensor. I don't know if you can see it. It's down over there, and here is its harness. So this over here is the harness for the second O2 sensor. Okay, so O2 sensor bank 1, sensor 2. So, and the harness is not touching anything. I mean, although this bracket is kind of hanging and it's rusty, okay, but the sensor, I mean, I can touch the sensor. I don't know if you can see my hand over here. I'm actually touching the sensor right now. Okay, so the wiring is not scraping against anything. the wires are not shorted. I can basically inspect the whole harness. Everything looks good. We gotta make sure that the signal that's coming out of this sensor is gonna match what we saw on the scan tool. So we're gonna back probe the signal wires, and the signal wire, I mean the two wires from the sensor that were going to the computer were the black, so black wire with this red tracer, and then I think it was the brown wire. Actually, I'm gonna double check on the wiring diagram, but the connector has 4 wires. 2 wires will be for the sensor here, and then the other 2 wires will be for the actual sensor. So one of these wires will be the signal wire for the O2 sensor, and these 2 wires are the wires that are going to the engine computer. So I'm gonna double check the wires on the wiring diagram. I will back probe them, okay? I'll get these wires back probed, and then I'll bring you guys back up so we can start the vehicle and see the signal that's coming from the sensor. So I'll do that, and then I'll bring you guys back up. Alright guys, so I back probed these 2 wires. This is the second O2 sensor electrical connector. So I back probed the black wire with the orange tracer, and I also back probed the white wire with the blue tracer. And these 2 wires are coming from the computer. So one of these wires will be the sensor signal. Now let me show you those 2 wires on the wiring diagram. So right over here, okay, so we have the black wire with the orange tracer, and then the other one is the white wire with the blue tracer. And we followed these 2 wires. They both go to the engine computer. Okay, so I have test leads that are long enough. These test leads are pretty long, so I'm gonna take the scan tool with me inside the vehicle so we can start it and test this O2 sensor while the engine is running. So let's go inside the vehicle and test the sensor. If we see a fixed signal coming from the sensor on the lab scope, that will tell me that the sensor is defective. At that point, I will feel comfortable replacing the sensor, because I will know that the computer is not lying to us. Because we're gonna start the engine, we're gonna cause the engine to run lean by pumping the brake pedal. If by causing the engine to run lean, the signal over there doesn't change, that will tell me that the problem is just the sensor, not the computer. Okay, so now let's go inside the vehicle and test that. Alright, so we are here in the vehicle, everything is hooked up. So let's back out of here and let's go to our scope multimeter. So let's go to lab scope, 4-channel lab scope. So let's turn on our first channel and our second channel. So we are on the 5-volt scale. We see 5 volt on the green trace, but we don't see anything on the yellow trace. So let's increase the voltage on the yellow trace. Let's go up to 20 volts. So let's put some D0 numbers here. So it looks like we have battery voltage on the yellow trace, and then we have 3.6 volts on the green trace. So looking at these voltages here tells me that the wiring is good, okay? The wiring is good on the electrical connector of the O2 sensor. This voltage is coming from the computer. So now I'm gonna start the engine. Okay, so our voltage is increasing. We are reading 5 volts on the green trace, and we are reading 14 volts. So basically battery voltage on the yellow trace. Now let me try to increase my time base and let's see what happens. Okay, so we have some type of activity here on the yellow trace. Okay, so we have 14 volts on the yellow trace and 5.47 volt on the green trace. So now I'm gonna pump the brake pedal to drive this lean. So this over here, so the green trace is our signal wire, and as you can see, it's stuck at 5 volt. Okay, I mean we had some activity there, just a little bit. I don't know if you saw that, because as I'm pumping, I don't know if you saw this right over here. See this? Barely noticeable. See, we had some dropouts there, so there was some type of activity there. There is definitely a problem. Let me put, now I want to look at the data and the scope at the same time. So here's the data. Let's graph the O2 sensor data PIDs. So here are the O2 sensor data PIDs. So this is the first O2 sensor, this is the second O2 sensor. So now let me back out of here and let's go to guided component test. This is a Mazda 2.3 liter. Go to engine. Let's go to, at this point you can basically pick any sensor, but let's go to oxygen sensor. So rear O2 sensor. So let's go to view mirror. Oh, it says scope is already been used. Okay, because I'm using the scope right now. So now I'm just setting up the scales. Okay, so let's turn the second channel on. Let's drop it down to 10 volts, so right there. Let's turn off peak detect, so let's click on mirror. Okay, so here is our now let's back out. Let's click on scan tool. So here's our data. Now we're gonna click on lab scope, so we're gonna bring our lab scope over here. So now we can see the lab scope and the data over here, and as you can see, so the signal is the green trace, and as you can see, there's no movement on the green trace right over here, and this trace is mirroring the data we have here on the scan tool. Okay, so it looks like the sensor just woke up. Now we have some type of activity here. I don't know if you noticed, but I saw the change on the scan tool happened immediately basically, but it took a little longer for the scan tool to update that. Let me see if I can back out. So right over here, you see this change? It took a little while. Of course on the scan tool this is processed data, but right over here there's definitely something. We had activity over here. See right there? So it looks like this sensor is not responding as fast. Oh, it was stuck. As you can see right now, this sensor is starting to respond. Remember before there was a flat line here, but now we have activity here. So this sensor is now working. Did we just fix it? What did we just do, guys? Did we fix it? I mean, maybe because just back probing stuff or wiggling connectors can wake up sensors. So maybe that's what happened. Now, let's drive this lean and see what happens. So now I'm driving it lean. I'm pumping the brake pedal. Okay, I'm pumping the brake pedal, and now watch this. You see how it went down? And it wasn't doing this before. You see, it's actually increasing on the lab scope. Actually, let me put some D0 numbers here. See, right now we're reading 1 on the lab scope. Watch this. On the lab scope we're reading 1.26. So our signal wire is the green trace. Just focus on the green trace, guys. The signal wire, the green trace, is this graph over here. But the lab scope is gonna update faster than the scan tool, because on the scan tool, that's not live data, that's processed data. Okay, the sensor reports to the computer, then the computer reports to the scan tool, so that takes a little time. So right now we're reading 1.25 volts right over here on the lab scope, and here on the scan tool we're also reading 1.245 volts, so 1 volt point 2, and same over here. Okay, so the sensor is not working right now. If we erase the trouble code and deliver the vehicle to the customer, everything will be well. But since this sensor triggered the code, I believe this sensor is not working intermittently. I'm glad we were able to catch it in the act, or maybe just back probing those wires fixed it, or maybe we had a pin fitment issue. I don't know, because right now it's working. Knowing that this sensor is a problem, I'm still gonna replace it. Okay, now that it's working, I'm not just gonna give it to the customer because now it's working. I'm going to replace it. I'm gonna put a new O2 sensor in it, and then everything will be fine. Okay, so now I'm gonna drive this sensor lean again by pumping the brakes. Let's pump the brakes. So right there we just dropped, and we're gonna get the update over here on the scan tool. Okay, so right there. So now I'm gonna let off. The lab scope is gonna update first because this is coming from the sensor. You see how the lab scope is starting to go high now, and we update it over here. Okay, so at this point the sensor is working, but I'm going to replace it. Okay, I'm not gonna leave it this way. Once we replace the sensor, this will be fixed. We made the right call. The problem is the sensor. I don't have to show you the after, because if I install the new sensor, it's gonna act the way this sensor is acting up right now, because I believe the sensor was stuck, maybe because these O2 sensors sometimes can just stick, and then when you start to play with wires and stuff, that can wake up a sensor. So like I said, I'm going to go ahead and replace this sensor. I'm not gonna give it to the customer because it's working now, because right now everything is fine. It's now working, because remember before it was stuck. We had a flat line here, we pumped the brakes, nothing happened. But right now when we pump the brakes, the signal here drops, so we are able to drive this O2 sensor lean and rich. Okay, because after pumping the brakes, you see how it's like pegging back up. So I'm glad I was able to catch this sensor not working on camera, because these can be hard to catch sometimes. I believe this sensor is failing intermittently. Okay, because right now it's working. So I'm going to replace it. Let me turn off the engine. So right over here, key off, engine off, we are reading 0.5 volt on the second O2 sensor, and we're reading the same thing on the lab scope. So this here is a bias voltage that's coming from the computer. So that's it, guys. I'm gonna leave it right over here. Let's get the scan tool out of the way. Hope you like this video. If you like the video, give it a thumbs up. If you don't, give it a thumb down. But if you do, you gotta tell me why, so we can make better videos in the future. If this is your first time here, subscribe to the channel. Ring the bell so you can get notified every time I upload a new video. If you have any comments, questions, criticism, leave them in the comment box. Thanks for watching, guys. See you next time. Alright guys, so I have ordered a new oxygen sensor from the parts store, and here it is. This is the part number. This part number is for the O2 sensor after the catalytic converter, okay? So let's get it out of the box. Let's see. So here it is. Here is our oxygen sensor right there. We're gonna install this one on the car. Installing this O2 sensor is really straightforward and easy to do. I mean, the size on this nut is a 7/8 size. So you get your wrench, you undo the sensor, and then you disconnect the electrical connector up here. And then once you get the old sensor out, you install the new one. After you tighten it, then you reconnect the electrical connector. So it's as simple as that, okay? So I'll get this O2 sensor installed, and then I'll bring you guys back up so that we can erase the trouble codes. Alright, so here's the new O2 sensor. We're gonna install it.
Cool.
Alright guys, so I got the scan tool connected. So let's scan the engine control module. So let's back out and erase the trouble codes because we replaced the O2 sensor. So let's clear the codes. So DTC cleared. Let's exit. So let's double check just to see if we no longer have any trouble codes in memory. So let's go to pending codes. Right there, no codes present, so that's good. So now let's start the engine. And as you can see right now on the dash, the check engine light is off, so everything is good to go. So right now we can deliver this vehicle to the customer. Okay, so this is fixed. I'm gonna turn off the engine. So right there. Thanks for watching, guys.